Okay, 16, we want to find the zeros and domain. And then we're going to do the same thing, but make it a rational function. So zeros of a polynomial, pretty simple. You just set each factor equal to 0, and those are the zeros. So it's the opposite sign, right? So we've done this before. X equals -7, x equals -3, and then the last one would be +5, because you would add 5 to both sides. So a polynomial just has an infinite degree. Like if I graph that, x plus 7, x plus 3, x minus 5, it goes on forever and ever, left and right. Remember, our domain is our x values. So polynomial, the domain is -infinity to infinity. It goes forever left, forever right. But what happens is we do 1 divided by all of this. Ooh, things change. We get some asymptotes going on. Look what happens when I zoom in. We get domain that's broken up into 4 pieces. Do you see how there's an asymptote, there's an asymptote, there's an asymptote? And those ones that we solved earlier, -7, -3, +5, those become our asymptotes. That's where the graph breaks. Okay. So I'm going to go here and find the roots of k of x. So roots are the x-intercepts. So x-intercepts, I don't think there are any. Yeah, when you set the numerator equal to 0, there's none. So we're going to enter none. So domain is we go from -infinity, and then we hit our asymptote at -7. And then we pick up a -7 and we go to our next asymptote, -3. Then we pick up a -3 and go to our next asymptote, 5. See the pattern all the way to infinity. So our breaks are happening at our asymptotes. So 7, -3, +5, -infinity, +infinity. And then there's no roots, there's no x-intercepts because it's 1 on the top. This one has a long domain. We have to enter every asymptote. -3, -3, 5, 5. Okay, and so every time I put an asymptote in, oh, something happened. Oh, I forgot the negative. So whenever you go check, like if you get something wrong, look, I did -3, and then here I didn't even write it. It's a -3, +5. So I'm going to check again, and we're good.